It's not even connecting. One second. Connecting. Alright, excellent. Cool. Exercise 2BC, you're dealing with literal equations and coordinate geometry. Now, if you remember from last year in Specialist, that's probably your first exercise or so, just transposing equations. So most of it's easy from 2B. Coordinate geometry, you have to know your properties. So it's coming from key knowledge dot point 1. You need to know your distance formula between 2 points on a segment of line, parallel, perpendicular, and then how to find axis intercepts and whatnot. So that's what 2C is about. That's what I'm saying. If you find that this is pretty easy, go back to and revise chapter 9 for tomorrow's test. Otherwise, 2B and C is just revision of linear equations of Specialists last year. Okay? So you can see you got to know how to transpose literal equations. Got to be able to solve using elimination method. So simultaneous, either use elimination method or substitution. These are the dot points for algebra, area study 2, and dot point 6 and 7. So those are the skills. You have to be able to do this without a calculator and to do it with a calculator as well. Okay? Here we go. Let's have a look at some of the problems we're going to be doing. So, 2B. Very simple. What's a literal equation? It's an equation without numbers. Okay, it's an equation where you have just parameters and letters. So for example, y equals mx plus c is a literal equation. Okay, y equals ax squared plus bx plus c is a literal equation. And if you're solving for these two, meaning you're solving for a straight line equation where it intersects a parabola, the intersection is what you're solving for when you say equate these two. And the skill to equate them to without numbers and to write out a general formula is what 2B is about. Okay? So let's have a look at some of the questions we're going to do. What? We are going to look at this. So it says for the first one, solve the literal equation. Pretty straightforward. Back to year 11 specialist maths. If you're solving for x, same thing with the first one. We can say, all right, you got ax plus n. And simply inverse operations. What would you do first, Pius? You want to solve for x? Yeah. Minus n on both sides because we've got a positive n, subtract n, cancels out, and then you get the next step. You say divide both sides by a, and therefore you get your formula or just rearrangement. That's what you're doing for 2B. Does that feel easy? Yeah? The only times it gets obviously difficult is when you're dealing with, let's say, n. Okay, and a lot of students find fractions and whatnot. The first few is always easy. And that's why I'm saying if you want to study smart, don't study hard. There's no point doing A, B, C, D when you can already do all this. Go down to N. Do like L, N, and P. See if you can figure it out. So if we were to do N, actually I want you to have a go with this first before I give you the solutions. I want you to solve for X for me. What would you do first and how would you do it? Okay? Hint. You hate fractions, collect them and then remove them. That's the hint. Collect the fractions, meaning combine these two together. Then you'll have a numerator denominator. Numerator denominator. You can flip it if you want. You can remove the denominator however you want. That's an easier approach if you want. Okay? So if you don't like fractions, remove the denominator. It's always the tip I give. Okay? What you can't do is you can't do this. You can't say, all right, I'm going to flip these two and then becomes x plus 3a on 2, and then you can't just say then that becomes x plus 2a on 1 plus 1 on x plus a on 1. Why can't you do that? I mean, they say whatever you do to one side you do to the other. Why can't I just say, all right, flip this side and then flip that side just the way I just did? Why is that wrong? Why doesn't that work out? Why can't I do that? You want to have a go? Because sometimes that's what I see with students doing it. And it shows me that they don't really understand what they're doing. Yes, Josh?
When you're flipping it, you're like timing both sides by equal denominators. Whereas...
Yeah, you're right?
Yeah, no, right, yeah, okay. But then you're not really doing that if you're trying to flip, like, with this addition, because then you're... Yeah.
Exactly. It's that addition that makes the problem. The addition is a problem because you've got two separate terms when you're flipping this one, you're saying numerator denominator, yes, you are just simply times by its reciprocal. Okay, that's why it flips around. Now, you can't do it with this one because you've got two terms. If you times it, you get whatever groups of whatever it is for this one, and same groups for this one. That's why it doesn't work out. That's why I said the only way to do it is if you combine the two fractions first. So if you combine it, you'll get something over something. By that time, yeah. If you want to do the reciprocal of both sides, it's perfectly fine. There's nothing wrong with that. But you can't do it when there's two terms. You have to do it when there's one term. It could be a plus b divided by c. That's fine. That's still your numerator. That's still your denominator. That's one term. It's when you have separate denominators, that's two terms. Okay? So the first step is to combine the fractions. And then if you don't like the denominator, you can do the reciprocal. Or like what you did in, what do you call it, year 8. You would have had something like this. If you had 3 on A equals to, I don't know, 2 on B, you learnt the cross method as well. And so you can say 3B equals to 2A. You can do that for this as well, once you've combined that fraction. Okay, and the reason why this works is because you're multiplying both sides by B, and then multiply both sides by A. That's why you end up with 2A and 3B. Okay, so if I multiply this by B, multiply this by B, B's cancel out and you get 3B. If you multiply this by A, multiply this by A, A's cancel out and you get 2A. That's the logic to the cross multiplication. Okay, so it's always balancing the equation. Everything you're doing in mathematics is balancing the equation. Here we go. Or another way of thinking, yeah. Oh, this is a really ugly long one. I don't have enough space here. Maybe there's a quicker way. Is there a quick way? What's the quicker way? Yeah, that's so ugly. Yeah, okay. Oh. This is so ugly. Has anyone figured it out? Negative a on 5.
Find x.
We'll find x.
Then we're done. Answer.
There has to be something I'm not seeing. It can't be that long. That takes too long to do. Let's move on. I'll figure out this one. There has to be an easier way. This is going to take too long to do. I'll figure out an easier way. Let's move on for now. Alright, let's go. Yeah, but then expanding the top just seemed like it was going to be a problem. Did it cancel out? Did it?
So you end up getting 2 times x squared over, and then you get 1 times x squared plus x squared. So the x squared cancel out.
Did you, so you did a cross multiplication of these two?
So I did, so x squared, x plus 2a brackets times x plus 3a plus brackets x plus a times x plus 3a. And then equals 2 times x a times x plus 2a.
Did it cancel out?
Yeah, well then you get, make sure you have the same denominator.
Oh, really? I guess I haven't given it a shot yet. I'll have a look at it later.
Yeah, because then you get the numerator 2 times x plus a times x plus 2a, and then I'm having a 2x squared term. And then each of the other 2 on the left, you're going to have an x squared term, and then cancel out.
Oh, okay. It just didn't look like it was going to cancel out. That's why I couldn't be bothered doing it. Alright, I'll come back to it and we'll have a look. Whoops. Alright, let's go into the next part of the question. Solve each of the following pairs of simultaneous equations. For x and y, every one of these is a simultaneous equation using elimination method. You can use substitution if you want. I generally prefer elimination method. It's just a bit easier for me. And remember, elimination method is as long as you have one of the terms the same, that's ax and this is 1x. So if you want, you can change them all to be the same by multiplying both the top by b. So you multiply every term by b. And then multiply the denominator. You see, you've got by. You can say subtract the top and then the bottom and take out x's common factor. You get an x. Okay? So elimination method, as you can see, I'll go a bit slower here. All I'm saying is you just need one of the terms to be the same. If it times this by b, times this by b, times this by b, that gives me abx plus by equals bc. The second line, I've got that. I can say now, elimination method equation 1 take away equation 2. So BC take away D, BY take away BY, cancels out, and you've got ABX take away X. They both have a common factor of X. Take out X as a common factor, AB minus 1, and since it's times, I can divide both sides by AB minus 1, and I get BC minus D over AB minus 1. Okay? This is elimination method. It's up to you, however, whichever method you want to try, but that's what it is. You can use substitution method as well. And that's exercise 2B. Now, 2C, revision, distance between 2 points. This is just Pythagoras' theorem. If you notice, Pythagoras' theorem is this distance squared plus this vertical distance squared equals your hypotenuse, or the distance between the 2 points. So how do you find these two distances? It's x2 minus x1. Square that. Add that with y2 minus y1 squared. And that's your c squared equals a squared plus b squared formula. That's where this is coming from. Okay, c is your hypotenuse, which is ab. That's why c equals the root a squared plus b squared, which ends up being a squared plus b squared. Okay? Distance formula, midline, gradient, and the only thing that you had to remember was gradient is tan theta. Okay, and those are your points for exercise 2C. So you can see 2C is just revision, linear equations, distance formula, midpoint formula, and what the gradients are. Okay, you got your perpendicular and parallel lines. That's what 2B and C is. Okay, now I'm going to leave you with this session that you can either have a look at 2B, 2C to revise, or use chapter 9 to revise for tomorrow's session. Okay? Tomorrow's the test. Make sure to know your product quotient rule. That seems like the only issue that I'm worried about. And then differentiability, derivative graphs. Make sure to understand that. Those are the only two I want to do. And then we'll be ready. Now, you've got about, give it another 5 minutes, 5 to 10. You've got to finish around 3. Okay? I meant to let you out at 3:15, but hey, why not end at 3? Yeah?
3 is a nice number.
3 is a nice number.
3.
Meant to be 3:15. You'll switch on to the early meeting.
3:17.
No, I have to stay here. Why do we have a short day? There's a speaker coming down. They start at actually when they restarted. I was surprised when this was here. So the speakers are down there talking. I just have to go there and listen. Now I normally fall asleep. I'll put your earphones ready. I can't have my earphones. Just sit there, listen. I want to.